Happens. And we are live, it says. I'm Joe Hill, and my channel is Effed Up World, and you're watching it now. And I have the Deborium channel with me, and we're just going to be talking about whatever we end up talking about. Obviously, flat earth and globe discussion is the title, I think. So that's probably going to be the content we talk about, right, Andrew?
Yeah, it's going to be a lot of fun.
All right. So what would you like to debunk about my beliefs tonight? No, I'm just kidding.
Well, I don't know, like you were saying before the stream, we could talk about up and down and stuff regards to the biblical stuff.
Yeah, that's actually a really good place to start, I think, actually. One thing that I told Andrew that I was interested in chatting about is I feel it's something that is important, but it's a simple thing too, and it's basically the kind of the definition of what up and down is. Really, that's probably a good way to sum it up, isn't it?
I suppose, yeah.
Because it, basically, if we were on a globe and I was in Minnesota, which I am, and I said, where's heaven, or where's up, where's the sky, I would point up, right? But pause Joe pointing up at the sky, and then let's take the Beck from Oz, who lives in Australia. So if she's down there and you ask her where is heaven, or how do you point up, she would point up, and it would be two opposite directions on a globe, basically. And in the Bible, it seems to me that it's more of like a level thing, like you have first floor, second floor, third floor, similar to that, so like that we do literally have the plane of the earth, or the surface of the earth that we live on, and then we have the sky above us, and it's above the earth. So what do you gotta add to that?
Well, it clearly states that you can't reach it, so I don't believe that it is exactly a physical place that you could be, perhaps.
Ooh,
if that makes sense.
I agree with you 100%. I agree with you totally, man. It's a different kind of realm, right? Is what you're saying. Mm-hmm. It's a spiritual realm.
So it would be in a place that doesn't exist in the physical, so you couldn't really comprehend its physical place. It could be everywhere, yet nowhere.
Totally understand what you're saying. Totally do. Now, here's one thing that I've been kind of something I don't understand that I wish I understood is, like in the Bible, the stars are like God calls them by name, and they come out when he tells them to, or whatever. And they seem to be angelic beings, and by that I don't mean like a person up in the sky. I mean like an angel or whatever. Mm-hmm. And those are also spirits. They're also like spirits of heaven or whatever. So, can we determine if the stars are, let's just say this, if the stars were like angelic spirits or whatever, then obviously it would not be the physical realm anymore at that point where the stars were. I think. I don't know. What do you think? What do you got to say?
Well, well, basically, so if I get this straight, so what you're saying is that the stars are not physical.
I think, yeah, yes, that would be correct.
Well, I think more of a God calling upon the stars one by like name and them coming out was more of a reference to his power and his thought and his ability to comprehend. Because if he can name all the stars, which are uncountable, then you're dealing with someone that is obviously not human.
Yeah, and like I was saying earlier, like of a different realm, like of a not physical and not material, like we understand, right?
Yeah.
So that's could be could be an interesting, thing to actually talk about is where does the spirit, or the spiritual realm, where is that? Because in the Bible, it's obviously above the earth, the heavens, or the Shamayim, or whatever. It's obviously the sky, but how high,
Well,
and that's actually, oh, go ahead.
Well, I don't think it is in a certain direction. To like everyone has their own, like that. You look up to represent that being there, but I believe it's in a different dimension or some other realm that you cannot be. It could be everywhere and nowhere.
Do you think that realm is visible in our, to our physical realm? Could we see it? Or
no.
Is it more invisible?
I would say it'd be invisible. It'd be supernatural.
Okay. Yeah, okay, I get you. And this is something interesting that I've been coming to believing or whatever, or understanding, that the sun and the moon, it says God placed them in the firmament of the heaven. And whatever the firmament is, I don't know exactly, but the sky, it's in the sky. We know that. And whether it's the end of the atmosphere where literally nothing starts, like the nothing of space, or the emptiness of space, like the lack of air, basically the lack of atmosphere. Mm-hmm. At a certain height, it appears to disappear at about 60 miles or something like that. So like above that, this is really interesting to me, because this is what I've been contemplating, like in the back of my mind, or in the front of my mind often too, is what, like the firmament, it says it divides the waters from the water. Hey, look on the screen right now. It's the ISS. There's some footage I got of the ISS. Not bad, huh?
That's pretty cool.
That's a pretty good shot. I think that's my best footage right there. That's with the P1000, just holding it in my hands. Not very, and I slowed the footage down, obviously. But that's not a bad shot.
That must have been moving pretty quick.
Yeah. It's hard to film, man. It is very hard to film unless you have like astronomy. Is it Astronomy Now? I think he has a pretty sweet software and tracking, tracking telescope that does some pretty amazing things. I think he seems pretty smart. I'm guessing that he writes some of that software to track the ISS. That's what I'm guessing. I don't know that, but I think he has something to do with that software, because I don't know how a telescope, your normal telescope can't do that, but with whatever computer software he has hooked up to his telescope, it's got to be quite the setup. I mean, it's got to
yeah.
It's got to take really a minute to set it up. Oh yeah, I bet. But I actually like that guy. He's pretty cool. Another channel that, this is kind of off topic, but I actually wanted to sort of promote a channel that that was really cool yesterday. And maybe you've heard of it. Take Back Space TV. It's a guy that just not every day, but often he live streams the moon in 4K, and Saturn and Jupiter and stuff too, but mostly the moon in 4K. And then he plays some music. Maybe he makes the music, I don't know, but he plays some music and he talks about some stuff, whatever's on his mind. It's I don't watch it all the time, but I went there yesterday, and I got to preface this story. Sorry, I'm going off on a tangent. Are you ready, Andrew? I'm doing it.
Let's go.
Sorry.
Let's go.
It's not a big deal. It's not a big deal. But so yesterday, or I'll start a few days before that. My cat, she's been on my channel before. Cupcake. I don't know if you ever seen her. She's a cute little cat, and she passed away yesterday.
Yeah, I saw that.
The last 2 days, she just kind of stopped moving, and yeah. Oh yeah, you saw it on Facebook.
Yeah, it's
so it's a kind of a bummer of a day. You know how it is to lose a pet. Yeah, it's no fun. But I went to this channel. It was last night, and we'll go there a little bit later or something. I went there and just said hi to every shot or whatever. And then all of a sudden, someone asked me how I was doing. And I'm like, yeah, I'll be honest. So I said, I'm doing great, but it wasn't the best day of my life. I lost my cat today or whatever.
Yeah.
And they were so cool. I'm not sure. I think the guy's name's Chris. I might be way off though. I think it's Chris because I think I saw people in the chat calling him Chris. But he goes, "Oh man, I'm sorry to hear about that," and whatever. And he played a song for Cupcake, and while it was playing, he like drew a little cat on the moon. It was so cool. I was like, "What?" It just made my day. You know what I mean?
Yeah, that seems really
Roderick
epic.
is in the house. What's up, Roderick? Good to see you, bro. What does it say?
What up,
BRB,
man?
let me share. What is BRB? Oh, be right back. Good to see you, man. So yeah, it was really cool. It's takebackspacetv I almost said .com. YouTube channel. And I'll put a link. What I was actually gonna do is just so I have because that was really cool. I don't know, it was kind of really cool. Hey, Midwest Explorer and Sea Level. So I wanted to promote his channel, and also I asked him if I could mirror that live stream once it processed or once it was done processing, and he said no problem. So I'm probably going to mirror it on my channel. It's just footage of the moon and Saturn and Jupiter, but the chat in there had something special for me, so that was cool. Very nice people over there. So there's my tangent. Back to whatever we were on. I actually forgot where did I go off on the tangent? I forgot where we were at that point. Sorry.
Well, we can just talk about. Have you seen Woketown by chance? That channel?
Yeah, I love that channel. Matt Long, he's awesome. I like that guy. And now this is interesting because I think I watched that video on his channel. Mm-hmm. And one interesting thing that I'm not trying to interrupt you. I'm sorry, but I just wanted to kind of point something out is that there's a lot of things that quote the flat earthers unquote. Okay, so I'm kind of grouping them up into like a stereotype group of people that there's a lot of things that I disagree entirely with those people about. And I think you know exactly what I'm talking about. Like the ISS, like they say, oh
yeah,
that's just a fake CGI Hollywood basement swimming pool trick. And I'm like, no, it's not. You got to learn to use your eyes. You got to learn to do some research, because you know how the flat earther, I got to go off on a rant a little. You know how the flat earthers pride themselves on seeking the truth? Yeah, that's not anymore. It's not like that anymore. It's not. And I'm not saying, because I don't think I group myself in with anyone specifically. Yes, I'm a flat earther, but I'm more interested in the truth than of anything really. And so like when we're talking about landing Falcon 9 boosters, and these people, I love them to death, but they cannot comprehend that it's happening. And they can't comprehend that every time it happens, there are millions of witnesses in the surrounding towns near Cape Canaveral. I know. I stayed in Melbourne.
Watch the rocket launches.
Yes, you can be at home and watch the rocket launches. People get annoyed there because their car alarms go off 6 miles away. It's not something that you can just say it's fake. There's literally millions of people are at their homes and hear it and see it with their eyes every time it happens. You know, the landings that happen out at sea, okay, nobody's going to see that probably. But they land them in what is it, landing zone, whatever they call them, the two pads that they built out at Cape Canaveral. Mm-hmm. They land there. They land a 230-foot tall booster on those pads, and tons of people watch it. Tons of people film it. And if you went there, you'd experience it in your chest. It was like, it would shake you. And so there's my rant. They just say it's fake. They just say, oh, it's fake.
Yeah, I totally understand that. They've
never experienced it. So I can understand them doubting it. Sure. but you have to think a little bit. And like I said, they don't seek the truth anymore. They seek their bias.
Mm-hmm.
Oh, Sea Level, love you too. Good to see you. Roderick says fake sonic boom. Sea Level, that's something that you can't really do a
yeah, I don't know how
sonic boom.
I don't know how you fake that really.
That's heard for how long is a sonic boom? When they come back in, they do a triple sonic. Each booster does a triple sonic boom, and I don't know why, but they do. Boom, boom, boom. And it has something to do with the grid fins. It's like I suppose the rocket comes in. I don't want to analyze that because I don't know enough about how that works. But if you put anything on the side of the rocket that's sticking out, that's strong enough not to burn up or whatever, it could have a strong effect in making a sonic boom, or like a double boom or something. Maybe you know more about that. Maybe you want to talk about that.
Yeah, so it basically just because it's changing the momentum into sound, which therefore it's like decreasing its energy that it has when it's landing. So it kind of slows its fall, if that makes sense.
Arrests its velocity.
Yes.
Exactly. So, and what happens is the rocket is plummeting to the Earth from the upper atmosphere at speeds that are much faster than 767 miles an hour. So, I'm not saying that this is like something that. What it is science accepts the spiritual, or the not spiritual. That's a bad word. Science accepts the unbelievable, or the like not explainable. And what I mean by that is a rocket is falling faster than the sound it is making. Okay, so when it comes down, you hear nothing. You don't hear anything because the sound's not there yet.
Yeah.
The rocket made the sound, and the sound is still traveling to you, and it's a time filled sound that it every second that it falls, it's probably silent when it's falling, but when it fires for the landing burn, which is how long is that? 30 seconds at the most. It's not even, I bet. It's probably like 15 seconds. The final landing burn. Like they've got it down pretty precision.
Yeah, it's
so what you hear is you see the rocket come down, and just picture the sound just not able to travel quite as fast as the rocket. So start way up at the sky and let it fall for a while and let it get a head start on that sound. And so the rocket's now it's going twice as fast as the sound that's following it. But it still made the sound at the point where the sound is. It's just didn't have time to get there yet. Now that concept is something that you can see with your eyes. If you watch a jet break the sound barrier and you see that atmosphere, it looks like it's stretching it forward. You know what I'm saying? But it's there's a lot happening there. But what I'm saying is that this is the sonic boom it isn't something that anybody should even try to debate. It's just something that happens when the rocket falls. Yeah, well, I'm just saying that this consistently happens every time. When the rocket falls, it falls faster than sound. The sound comes, like if you see a video of it, the sound comes depending on your distance. That's when the sound comes, is how far away you are from where the rocket's landing. You're not going to hear it, and the rocket will land or whatever. And if you're far enough away, then you're going to all of a sudden hear engines firing. The rocket could already be on the ground, but the sound's just going to be getting to you. You'll hear engines fire, and you'll hear them for about 15 seconds, or you'll hear the first is boom, 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 because the sound's coming at 767 miles an hour, right?
Mm-hmm.
I think that's right. But so then you hear the sonic booms, and then immediately after the sonic booms, you hear the rocket, the booster, firing. So it's a strange thing, but once you look into it, it's just something that science accepts, and that I accept because it happens, but it doesn't really explain how that can even possibly happen. I don't understand how that can even possibly happen. It's like, make the sound here and then go over there, and then the sound's going to follow you.
Well,
I don't know.
I guess to understand that better, you'd have to think of what actually sound is. It's like a compression in the air. So like the molecules in the air, they're bouncing against each other, and then when that hits your eardrum, that's how you receive sound. It's like think of it more like if you drop a pebble in a pond, that wave.
Yep.
So if you make the sound and you're traveling faster than the molecules in the air are moving, then the sound will be delayed.
Because the sound has to travel like in a wave, right? Or like a like a wave.
And that has kind of a set speed depending on the density.
Well, it needs
the air.
atmosphere. It needs the atmosphere in order to what is it called? Reverberate the sound or whatever it's called to push the sound along. You need some sort of medium.
Yeah.
Like if you go underwater and you scream or you hit the bottom of the pool with a hammer or something, you go underwater. It does not sound normal.
No, that's because sound actually moves quicker in water.
Okay, yeah. Is it because it's more dense than the air?
Yeah, the molecules are closer together and they'll hit each other quicker.
And so it's like almost instant, like in a swimming pool. It's like almost instant.
Yeah, and then if you like do it on something like solid, like an iron block, the sound would probably travel the fastest.
Okay.
So it's really just the atoms compressing and then sending out a wave.
Okay, so back to the fake ISS. So
it's all CGI. It's all CGI.
Yeah, it's all CGI. No, see, here's the thing: is this is interesting to me, and people might not share my perspective here, but this is my perspective, so I'm going to share it. It doesn't mean I'm right. Doesn't mean I'm saying I'm right. This is just my perspective. Okay. At first, when Flat Earth came into my mind, or when I started thinking about it, I started seeing stuff on the ISS that what did I say, Andrew? I always said CGI, didn't I? I don't know if you see my channel. Like 2 years ago, I was saying space is the fakest thing. It is CGI. Like the ISS is all CGI. Whatever's up in the sky, I don't know. That's basically what I was saying.
Yeah, I have been following you for about 2 years. Yeah,
and I still was filming it. I was filming it, seeing the shape of it, not understanding what it was. Okay, when the simplest thing is just to pay attention to what it is. They built it. They send it up in little rockets and the space shuttle. They built it with the shuttle, and there it is. Okay. And I mean, this is a loop video that I'm playing in the background, but that footage, I don't remember exactly where it is, but that footage that I got of the ISS, that's going to be hard to argue with that. And that's just Joe Hill, carpenter guy with his camera. Okay. Good. If you want to see it, you go to U.S. Launch Report. They have one of those automatic pull behind your car telescopes, that tracks a rocket launch, and it tracks the ISS, and go to Astronomy Now, and he's getting into that now.
Red's Rhetoric, if you know that channel, he did a collab with Astronomy Live, and
of the ISS.
Yeah, of the ISS, and they caught the moon transit, and then they did a whole bunch of math, and they showed the speed that it was traveling, and they figured out the size it was based off the parallax because they had two observers at the same time. And so there is something physically there that is traveling that speed.
Yes.
So,
and
that's basically what they concluded.
When people say you're saying you can see the size of the angular size of a football field from 260 or 70 miles away, and I say, yes, you can if it's a beam of light. If it like why do they do laser tests when they're trying to see long distances for flat Earth tests or whatever? Why do they use a laser? Why don't they
Yeah.
just like stand there with their hand? Yeah, see my hand? Because you can't see a hand from that far. But you, okay. An example. What is a lighthouse? What is a lighthouse for? You know what I'm saying? It's
Yeah.
because how big is the light in the lighthouse? The size of a
Pretty
basketball,
massive.
right?
It's pretty massive.
Let's just say it's the actual bulb or whatever. Let's just say it's the size of a basketball, just for an example.
Yep.
Are you telling me that you can see the angular size of a basketball from 60 miles away? You know what I'm saying? Like, it's the same thing. You can see the light, but you if you zoomed in on it with a camera, you are going to see, like the video I took of the ISS, it's going to be a little fuzzy, or like the better camera and the better zoom and the better optics you have, the better image you're going to be able to see. And the better air, the cleaner air or the better atmosphere conditions, all of that. But the angular size really has nothing to do with it, I don't think, for seeing it at that distance. But so I wanted to talk with the chat because I love the chat. Sea Level says, praise the Lord. Awesome. So then she says, that would be me when I said, the CGI, the space station is CGI. So I want to be clear, if I can, just about what I'm trying to say. Okay, there we go. Yeah, she said the ISS being fake. That's me. Okay, so the thing that I would encourage Sea Level to do, and I'm not saying like you should do this or something, but if you think it's fake, but there's a whole organization of people that have spent 20 years maintaining something in the sky that they say they're doing this, right? They claim they're doing this. Well, what I had to do to understand what it was probably started about 4 years ago when I bought a P900. And then I realized, hey, I can maybe get decent at following this and getting it on camera. And how many times have I filmed it? Oh, hundreds of times, trying to get a better shot every time. And it's really hard. Like out of 10 times that I film it, only one video ends up being like worth watching. It's just like a white dot otherwise. You know what I mean? You have to have like the conditions have to be perfect and the settings have to be perfect. But
yeah, it's a good thing it does transit so often though. So
because that helps add veracity to its the realistic factor of it, you're saying. Yeah, and that's true. Like a lunar or a solar transit, you can really see it. You can see like the skeleton, the shape of it or whatever. But so whatever it is, there is something up in the sky, and we can triangulate from the ground, and simple math, we can see that it's now, if you're on a curved surface, a globe or a flat Earth, and you triangulate something, the distance apart you are, you're going to get a slightly different, you're going to get actually a decently different height, but it's not going to be 10 miles. That's what I'm saying. Whether you're on flat Earth or globe, and for the math, and you triangulate 2-3 states away, you view it, get the angle, do the math, you're going to see that it's, I bet you if you were, you might have like a few miles distance difference, or I mean, more than a few miles, maybe 20 miles in height difference on a flat. And so it's almost a non-factor there. But what I would encourage people to do, because I'm not trying to say that the space station is something that I think is a good idea. In fact, I don't. And I think I've made it clear that I think it's actually the beast that John saw in the Revelation. And it was the beast. It was the 8th wandering star up in the sky. I mean, that's a serious thing, obviously. And I know you know that, Andrew. But but that's me saying that doesn't mean I'm right. But so I'm not telling people like, yeah, it's a good thing to have a space station up there. What I'm thinking of it is this is just the, if you take the most potent materials for combustibility, or what, if that's a word, the most combustible materials and efficient, and this is what rocketry is. Okay, I personally believe it's like wizardry, but it is a $400 billion a year industry in this world. It's not a fake thing. Just imagine that. Okay, I don't think I don't think any of these flat earthers are going to say that F-16s are CGI or they're fake and they don't fly. They can't fly that fast. Like, okay, it's only when you step up to the space vehicle, which we're talking about, like the shuttle Mach 25 or 22 or whatever. It is a crazy sounding speed because we live in an atmosphere. Okay, so if you go out of the atmosphere, whatever that may be, you don't have, your vehicle doesn't heat up. Like go fly a F-16 as fast as it'll fly, or I'm just saying F-16, whatever kind of fighter jet or whatever. Go fly as fast as you can fly it, and take a temperature reading of the outside of the vehicle when you're at as fast as it can fly. You wouldn't be able to touch with your hand, I bet.
Yeah.
It's like very hot, very hot. And that's only because it's in the air. Like, stick your hand out the window while you're driving 55 and you get quite a decent amount of drag on your hand. Well, now multiply that times, it would be times 10 times faster. Wouldn't even be as fast as the speed of sound. So 10 times that drag on your hand would start to get warm.
If you had a hand at that point.
Yeah, exactly. If your hand didn't fly off. But the thing that I think is important to at least think about when we're talking about if the space station's real or fake or whatever, what it is that NASA, if you don't like NASA or they're liars or whatever, that's fine. I'm not talking about NASA as a company. I'm talking about do you even know how many people NASA employs? I don't, but it's way up there. It's like a lot of people. And all those people that they employ are not lying. They're not in on a lie. There's no conspiracy at NASA that the people are doing. There's nobody going home going, man, I hope we don't get busted for this lie. That's not what's happening. And that's why it's a lot more, I'm sorry, I'm rambling, but it's a lot more important to look at the details, and if you want to understand what the truth is.
Exactly.
Because I believe that we can know the truth about things, and it doesn't mean we understand it all. We're just talking about, where does this spiritual world start? I don't know. I know that it says that the sun, moon, and stars are in the firmament. So to me, that would be, it's celestial. So I'm thinking that would be spiritual. But there's a lot of things that I don't know. What do you think, Deborium?
Well, I think that's a really good point. You could always keep asking why. Like in science, you could always keep asking, why is it that way? Why does this work? And then you'll get an explanation. And you ask why again to that explanation. And you'll just keep going down and down and down. And then you're going to hit a point. It's just, we don't know. It's just how it is. And I feel like a lot of people on both sides get really stubborn on that, of just saying that, I don't know, there, I got you, you don't really know what's going on.
We have someone in the chat, not to cut you off. Brandon, yeah. FCC, are you saying that you want to join us? Because I'd be open to do that, I think, as long as you keep it civil. I don't think I've seen you here. Maybe, let me just check something.
Yeah, I can go to his channel real quick, check him out.
Yeah, could you? Otherwise, I can too. Last time I did this, I was like, I added someone. What did they say? They're like being.
They called you sexy.
Okay, yeah, that's what it was. But it was like a dude. It was like a dude.
Yeah, it was.
I'm like, oh, okay, that was a.
It was
Yeah.
interesting. It was interesting.
I don't have a mic. Oh, okay, okay. Well, welcome, Brandon. If you have a cell phone, you can join. I think pretty easy. You can actually, Deborium could probably explain how did that process go for you, Deborium. I think you're on.
Yeah, I'm actually on my phone right now. Actually, I just have a headset plugged in. But if you really want, you could just have your phone sitting on the table and just speak because your phone has a microphone on it. So, yeah, I think you'd have to email him if you wanted to send him a link.
Oh yeah, unless we were friends on Facebook or something. Yeah, you're right. Let's see. How would we do an email? You could put your email in the chat, and then we can delete it if you want. So it's not in there. Whatever you want. He was talking about sexy in the clouds.
He's on.
I'm on my laptop with the mic. Oh, okay. Well, hey, what did you want to? I might have missed your. You said, okay. Do you believe the Earth is flat or a globe? Okay. I'll tell you what I believe, and then Deborium will give you his thoughts. I believe. Now, if I'm going to be specific, I can't say that the Earth is flat or a globe, but I can say that I observe no curvature, and I observe, mountains and hills and valleys, but overall, they're all on a flat realm, I'll call it. And I don't know about the edges. I just know that I think there's ice there at the ends of the world. I don't think we can ever really get to the very end of the world or something. I think God made it that way. But I know that I'm positive that we're not on a spinning Earth, because look around, it's not spinning. Now, Deborium's going to add to that his, because there is a relative explanation of that, isn't there, Andrew?
Of course there is. There's always a relative explanation.
So what do you think, or what do you think about that question, flat or globe, and all that?
Well, to me, it is obviously a globe. But probably from the experience I've had, because I've dealt with flat Earth and globe discussions, I've been really following it. It's almost turned into a hobby at this point. I really enjoy it. But with the relative motion of it, it is, if you do the math, you would never feel it spinning, because it's only the centrifugal acceleration is only about, it's 0.03 meters a second squared. So that's not very much. It is something, not very much. And when you compare that to the downwards acceleration, 9.8, it ends up being less than 3% of it, or just a little bit more than 3%. And that is actually measurable, and you can see that you can experience it, you can observe it and demonstrate it, among other things. So I feel like that's ample enough evidence for that case.
Well, that was a pretty good explanation. Although I could throw a monkey wrench in it for you if you want. Should I?
Do it.
Okay, I'll try to anyway. Can you, and what I mean is without a device of any sort. Now this I'm not talking about like science, because if we're going to do science, we're going to use instruments, we're going to use things to measure things, we're going to use scales, and we're going to use formulas, and because that we can find out more. Mm-hmm. But as far as like the bare bones perception and observation, and I guess perception and observation that we make just as human beings, because we do have some amazing senses. And like you said, you would not be able to feel the spin of the Earth, or you would not be able to feel the Earth going around the sun. So I understand that. But if I don't have an instrument, a meticulous scale, and I go up to the North Pole and take a, tear it and take a measurement, and then go somewhere else and do it, and all this, and we get I'll say consistent to the area you're in, you'll get a different weight or whatever, right? That would be a way to say it?
Yeah, different latitudes, it'd be different
latitudes. Okay. And now what I'm saying is that ample evidence to prove anything about the ground that beneath our feet every day moving? Understand, we get a different weight if you go to the North Pole and then you're at the equator or something. But that's just a different, to me, that's just a different area of the earth. It could be anything if you get a different weight. Like the air could be, have more lower hydrogen levels or something, and the medium of the atmosphere acts differently on everything. I don't know. What I'm saying is, to me, that is not something. It's not directly related to the idea of the Earth moving.
I see what you're saying, but the problem with that is it's exactly what the mathematics predict it to be if the Earth was the size it is, and it rotates once per day. You could basically make a prediction. If the Earth was that size, what at this latitude, what should be the centrifugal acceleration? And then you can go and then set an experiment. So you'd say, if the Earth is spinning and at that size, then you would see this change in weight. So then you would go there with the scale, and then you would observe that change of weight, and it would fall directly in line with the globe. But that's not the only evidence that I'm relying on. I think you're going on kind of, you're saying something about without instruments, without scales and stuff, right?
Mostly our senses. If we were to go by our senses, what would give us the idea that it was moving? Probably nothing, right?
Well,
I'm saying, like, if we don't have a scale, or we don't have, like, it sounded like you were just going to bring up another way that we can kind of get that idea. Go ahead.
Yeah. So, okay, so this, you seem, a lot of flat earthers have problems, like, oh, you're looking at the sky to do the shape of the Earth, but there's a little deductive reasoning you can do there. The sun, for every single person on the planet, regardless of your location, moves 15 degrees per hour, basically meaning that 24 hours is in a day. With that in mind, the sun being 98, 93 million miles away, it would predict it to be, if it was a rotating sphere, it would always have that 15 degrees per hour. But if you were on a flat Earth, that would basically mean for each observer in different positions on the Earth, the sun would have to be moving different to everyone at the same time to get 15 degrees per hour. So with a little deductive reasoning on that part, you could determine that it's either the sun is special for every single person looking at it, or the Earth is spinning and is a globe.
Okay, I think I do understand what you're saying, but I do doubt a couple things about that. I guess. Okay, let's see here. Well, give me a minute. You continue to talk. I think I might have cut you off before you were done there.
No, I think I'm done. But Brandon makes a good point that you wouldn't feel speed; you would feel the changes in speed. So
yeah, like acceleration.
Yeah, that's why I was kind of saying that the weight change is, there is a change in speed because it is not traveling in a straight line, and it is spinning. So you're changing your angular momentum, which that means you're accelerating in a different direction. So that's why you do experience a change of weight rather than there being none.
Okay, and again, that to me, and obviously, everyone's going to accept whatever they're going to accept or believe or whatever. But to me, that's not good enough of a. It doesn't really. I guess what I'm saying is, where I live, and I kind of always go a little extra here to kind of make it funny, or to kind of make it fun. I like to have fun. These discussions are boring when. Like when you watch Fight the Flat Earth and Nathan Thompson when they get together.
No, yeah,
it's not fun to watch anymore.
It's not. It's like
you guys
annoying and childish.
Stop with talking about each other. Why are they talking about each other? All Fight the Flat Earth can say is because you're an idiot. And then all Nathan Thompson says is kind of, he's like defending himself again. It's like, forget about the flat earth. Forget about Nathan. We're having a discussion about a subject, not about us.
Yeah, it'd be a lot of fun to actually talk to Nathan. That'd be very interesting.
It would. I actually plan on getting him on here one time. Maybe we should all do it together sometime. That'd be fun.
That would probably
Nathan's such an awesome guy. So
that'd probably be a dream come true, to be honest, because I was introduced to like flat Earth before I knew about you on Facebook, and I remember watching his type of stuff, and I was like, oh, if I could talk to him.
Yeah, like you're like trembling, like, oh, come on, don't believe that, or don't say it. Like, you're like, I gotta talk to this guy. No, I know Nathan pretty well. I met him at the Flat Earth conference in Denver.
You saw him in person?
Yeah, and he's like, I've never had him on or anything, but I've talked to him before, and we've texted and stuff. But yeah, I bet you I could get him on anytime.
He seems really cool, but he also believes some very, very, very wacky things, to be honest.
I agree. And you know what? That's the beauty, is like, I openly say Nathan is believing something crazy when he made a video with some JM guy. I don't like that guy at all, but he made a video trying to it was a debate, I think. Was it a debate trying to debunk, saying that their Astronomy Now's footage and Red Reddick's footage was faked? I'm like, oh my word, that's too far, you guys. That's just way too far.
No, yeah. I saw that video, and I saw the deconstruction of that video.
Oh, it's awful.
They got clowned very, very, very hard, because Red Reddick was, it's very entertaining when he gets worked up. That's all I can say.
Oh yeah, he goes off. He gets really offended and goes off. But you know what? I went to a Astronomy Now live stream soon after that, and I'm like, I want to apologize, because that is just outrageous. Yeah, and Astronomy Now was like, and I said I'm a flat earther, and he's like, well, thanks, man, because I don't know why they would say that try to say it's fake. It's like,
when in doubt, it's CGI, right?
Well, didn't like that. I just got reminded of something. Or there was a rocket launch, and there's like a little thing, Rocket Lab, where they say send pictures or it didn't happen. Like, I don't know why they would. That was like, I don't know what the deal was. I just saw that on a title on a lot of videos. It was send pictures or it didn't happen. Rocket Lab launch or whatever. And I think it was something they were saying like before it launched, and then they lost it. I guess they lost this was just a couple days ago, but that's off topic. But no, see, that's what I love about, like, Deborium and I can have a conversation. We don't believe the same thing, guys. We're in opposition to each other. But guess what? Mm-hmm. I love talking to Deborium, because we can actually talk about things and actually discuss subjects without letting something get in the way. Because something gets in the way a lot of the time. And it shouldn't.
I know. It's just, we're having adult conversations,
Yeah, and you know what? You can say something that I totally disagree with. It doesn't mean I'm not going to like interrupt you and be like, oh, no, you're an idiot or something. What does that do? That just stops the actual conversation we're having, and then it's hard to get it started back to where it was. So it's like, I kind of like doing, well, here's what I'm thinking, and what are you thinking? You know what I mean?
Yeah.
People can make their decision what they believe on their own, and it's just nice to hear several different points of view.
Yeah. Do you know MC Toon by chance?
MC Toon, I've heard of MC Toon. Is that, or no? I'm thinking of a caricature cats or something. What's it? Caricature cat, or what's the one?
Conspiracy
Cat. Yeah, that guy's funny. That guy's funny.
Yeah.
Like, obviously, the flat earthers and the globe earthers, they're always going to be like fighting each other, like or debating each other. So it shouldn't, like, I like Simon Dan's videos. I think he's crazy in some of the stuff he says, but I like to watch his videos because they're entertaining.
Yeah.
I
think that's kind of the way they're putting the content out there, like Fight the Flat Earth. At this point, he does do the conversations and stuff, but he's trying to do it in an entertaining way. Because I remember at the beginning of a debate, it was him and Team Skeptic versus I believe G-Man and Nathan Thompson. I'm not really sure what the topic was, but they opened up with the opponents on the team have a combined IQ of 50, and that's assuming G-Man has an IQ of 49. And I laughed so hard at that because
it's hilarious, and that's like that should be funny. It shouldn't be offensive because that's why they wrote it in there. They wrote it to be funny, not like they wrote it in there as entertainment, not to offend G-Man or Nathan or whoever it was.
Yeah,
and I think I did watch that one too. I think.
Yeah, it was good. It was good.
So back to the sun being 93 million miles away or whatever. That there is something we could talk about. To me, when the sun comes down through the clouds, and they're in this background video we're watching, there is a little bit of footage of the blue sky with some white clouds, and you see like these shadows, right?
The crepuscular rays.
Well, I don't know if they're necessarily called that in this case. It's like a black part of the sky, almost like a dark blue. It almost looks like would it be dusk, like dark, like where the sky's twilight, I guess.
Yeah.
Cindy Luheman, good to see you. Kelly Lowry, I'm just gonna say hi to the chat because I see some new people in there. Daniel, good to see you. Thanks for hanging out. And Brandon MCC, again, good to see you. Lee Redpath, what's up? Flatjacks is in here too, or was. I should have kept up with the chat a little bit better. Skywatcher footage, what's up? Dank, good to see you. Tim Pack, awesome to see you guys. Thanks for stopping in here.
I don't know if you want to invite anyone on to talk. I would totally be down to talk with whoever.
Yeah, I am too. Actually, if any, you know what I'll do is I will, because even if I put the link out there, someone can click in and they don't get on here until I add them. So I'm going to put the link for our stream, or how do I do that? Where is it? Okay, hold on. Give me a second. I'm going to put a link in the chat, and anybody that wants to join us for this fun conversation, more than welcome.
Mm-hmm.
So, and all you have to do, I believe, is click the link, and it's probably going to be mostly self-explanatory from there, I think.
Yeah.
So I'm chatting in the chat room. All right, there is the link, guys.
Oh,
and I will keep. Go ahead.
You were talking about like some sort of podcast, like a weekly thing.
Yeah, I think I want to do, like, now that I'm doing the StreamYard thing a couple times. You remember what, a year or two ago? I did this all the time. I did it all the time. I had tons of people on, and it was so much fun. And I learned a lot having people on. And so it's something that I'm definitely going to be doing much more now. So I was thinking if I did it like on a certain day each week or something like that, that people might be able to like count on it being there, and maybe there'd be, an interest for it. And whatever we end up talking about is probably wide open. I don't really have, obviously there's one subject that I'm interested in, but there's a whole world of stuff we can talk about within that subject even, So the sun, why do you think the sun's 93 million miles away? Oh, there's that footage. See that footage up there?
Oh, yeah.
Yeah, that camera was almost pointing straight up, right? And when I'm looking at it from the ground, that cloud's like almost directly above me. And there's those black, those dark shadow rays or whatever. They're pointing in all directions as if they were bouncing off the cloud or something and splaying out. You know what I'm saying?
Mm-hmm.
And to me, like, if we just go with like general geometry and, how if light moves in like a pretty much a straight line, it seems to me that the sun would be. Now I have another factor to add to this. So I'm not saying the sun's 60 miles in the sky, but it appears to be, quite a bit above the clouds, but not very high above the clouds. If you just look at those and like you were saying, crepuscular rays and anti-crepuscular rays. But if you're looking at those, it seems like the sun's not that high in the sky. But there's another factor that we have to add to that without forgetting, is that an example, my brother lives on the other side of the country in Florida, and he sees the same thing. And it looks like it's 60 miles above him. So how does that work? He's 1,800 miles away. You know what I mean? So to me, that could say something about this firmament celestial realm that God placed the sun, moon, and stars in. Maybe we see it, but maybe I'm not saying I understand it, but do you get what I'm kind of maybe trying to say?
Yeah, well, okay, I don't know. Is there... I'm going to see if I can...
Remember, I can go anywhere on Google. I can do a screen share and we can look at anything, website or any info or anything you need to look up to. So don't forget that.
Yeah, there's a specific image in mind. So basically, imagine you're in New York Times Square, right? And
okay.
You look up and all the skyscrapers. From your perspective, those skyscrapers are making that same sort of line pattern, yet that all the buildings are parallel. It has to deal with the perspective of how you're observing the light.
Yes, I understand that. But what about this? Here's a monkey wrench again. I hate to throw these monkey wrenches at you, brother, but I'm gonna. Okay, so we see that, and that is somebody. That's not the first time I've heard that. You know, like that we're standing on the ground, and as those light rays come straight down towards the ground, they appear to be going in all the directions as we stand there on the ground, because of just the same reason, basically, why a railroad track seems to disappear into itself as you look down it. You know what I mean? But the drone that I have can go up in the air pretty high, pretty much the height of the clouds, and it can look down at those light rays, and I can send it above my house where I know the terrain and I know the lake and I know the cornfield and the tree farm, and I can see those light rays hitting specific places on the ground that I know I ride my bike to or whatever, and these are not they're going outward from that cloud down to the south and down to the north. And so from the drone, you can get a different perspective and see that it's not actually parallel. So what do you think? I can actually pull up that footage if you want. I have it somewhere.
Yeah, do it.
I will search for it here really quick. Shouldn't take long to find it. Because there was those. Actually, you know what? I can play this video in the background while this is just an example of those things. There we go. And what he's saying is that those are parallel, and because of the location where I'm at, as I look, let's say the ones that are going down to the right towards the ground, those are going straight, but it appears that way because of basically because of the perspective from the place on the ground, the apparent thing that I'm seeing from that position, right?
Yeah.
And then I'm still looking for this video here of the drone footage of this. It's not the same cloud or the same day, but it's the same type of, light rays or whatever. And I think I know where it's at, but it might take me a second to find it. Let's see here. I can't remember what I named it or anything, but I think I know the folder that it's in. Flat Earth Proofs. That's a big folder I got, man. Hey, it's right here. Hey, guess what I named it? Sun rays are not parallel under the clouds. Let's watch this video. Just see what happens, right?
Well, with that name, I can't argue, you know?
Yeah, I guess. I mean, it proved itself, right? No, I'm just kidding. Okay, so see that happening? Do you see the light on the ground? There's the tree farm right there that I'm talking about. It's going over the river there. And back in the background, the light rays are going the opposite way. Do you see what I'm saying? They're not going parallel to the ground. They're not going straight down. They're totally going at an angle. I'll just let that loop for a while. just for the fun of it, I'm going to take my logo down. It's probably getting in the way. Sun rays are not parallel beneath the clouds.
I'm gonna see
Listen to
if I
me.
can't log into Facebook on my PC so that I could send you.
Oh, okay. Like a
Like-
link or something,
Yeah. Oh, I can.
or an image
Nice.
or something. Nice. You do that all from? Oh, you got your computer going.
Yeah, I got my phone and then my
Okay.
PC because my PC doesn't have any audio stuff hooked up to it at the moment. Yeah,
Let's
nice.
see here. Oh, I think I showed this to you the last time. Or yeah, I did. But maybe if the viewers didn't see it, got some construction going on here. Yeah, we gotta wait till Andrew can react to that.
I see it. I see it.
Okay. You know I gotta do that. Welcome, Solar Warden Studios, HDR and 4K. Good to see you. Anyone that's sober knows the Earth is not flat. No, anyone that's sober knows the Earth is not spinning. Only drunk people think the Earth is spinning, or people that have meticulous scales that travel to the north and to the equator. Right. Let's see here. I'm gonna read some comments while you're checking, while you're doing what you're doing.
Yeah, I'm trying to find.
Let's see. I'd like to say that comment doesn't help. I think Brandon's probably got a good point there. Isaiah 66, the earth is my footstool. Yeah. I'll read that verse. Isaiah 66:1. It's an awesome verse because this is one of the things that me and Andrew were kind of talking about was the, where's heaven? Where's heaven? Is that something we see? Is that where the sun, moon, and stars are? Where's God? Is he above that? Because there's darkness above the earth. This is clear. The flat earthers know this when they send up balloon footage. So that's not a debate. There's darkness above the surface of the earth everywhere. And the sun lights up the sky, so we get daytime, and the darkness is still there. We just don't see it during the day, right? I think that's right. And Isaiah, one of my favorite prophets in the Bible, one of my favorites. Let's see here. Kelly Lowry, thank you for putting that there in the chat. We got, whoops, I'm having a hard time getting there.
Yeah,
Isaiah.
I sent you the image through Facebook Messenger.
Okay, I'll check it right after I'll read this one verse. Isaiah 66:1. Thus saith the Lord, the heaven is my throne, and the earth is my footstool. Where is the house that ye build unto me, and where is my place of rest? Almost like a quiz. Like he tells you where he lives, and then he says, where's the house you build for me? I'm going to Facebook to check out what you sent me there.
I don't know. I'm just going to respond.
Yep. Okay, I see what you're saying. I'm trying to figure out how to get this. I think what I can do is, I can forward it, or can I download it? Or do I click on it? Okay, there we go. Then I can download it. Save image. Oh, wait, never mind. I can just move it to my desktop screen and do a desktop share. Whoops. Okay, there we go. I got it up, and I'll do the desktop here. Sorry, guys. Let's see. This should do it. Right there, I think. There we go. And I gotta maybe get a... It's kind of an odd view of it. Is that the whole picture, or are we missing the top half of it or something, like part of the half? I know what you're saying, though.
Yeah, so that image is... all those lines are parallel.
Yeah, definitely. Yep.
So
I agree.
It only matters from the specific perspective, per se, of that. So when you have your drone fly up, it just changes the perspective ever so slightly. But the clouds...
The angle of the... Okay.
Yeah.
Sorry.
But the shadows and the clouds themselves are very massive.
Yes.
So it will appear that the rays are going not parallel, but it's just the perspective of it. Because in this site, you can mess with the perspective of it, and you can see that they're all parallel.
Mm-hmm. Yeah, and I think that I obviously don't disagree. I mean, this is just part of the way we observe things. with our eyes. That's just how it works, right?
Mhm.
But what I'm saying, and I do get what you're saying, if I put the drone halfway up these buildings and I looked up, we'd get a similar image to what's on the screen, just different proportion. And then if I look down, you'd get a similar image again, but the opposite way or whatever. I understand that. I just have to say, let me go back to that video for one moment and pause it, the one from my drone, just so we can talk about it for a second. Because I'll show you something that I was kind of noticing. How do I do this now? There we go. Sorry, I'm a little slow here. Ooh, it's not working. Oh, there we go. Okay. I'll pause it when I can explain something to you, because I can actually zoom in on it and everything. Okay, right there at the beginning. Okay, now I'm gonna show you where the river is. Okay, the river's running left to right. It's kind of winding in the, I don't know if you can really see the actual river, but you can see where it is there, right?
Yeah.
Okay, that's the Rum River. It's a few miles from my house, probably 2 miles away from my house. And so back to not zoomed. Now this over here is the other side of the river, and it's like a neighborhood or whatever. I think this is like 7th Avenue or whatever is right here. So that sun or that light is obviously hitting there, right?
Mm-hmm.
And then if we look at these rays, they appear to be going left. Whoops, sorry. These ones here. They appear to be going left. That's like a farm. There's like, where's the radio tower? Just for reference. Should be a tall radio tower here somewhere. I guess maybe it's not the best image. Oh, I think, yeah, I'm not sure if that's even the radio tower. But look back here. Back there. I'm going to zoom out again, but back there where that light is hitting, going at kind of an away from us angle, it appears to be. That's lighting up like, not quite Elk River or something, but I guess what I'm saying is this cloud is not that large, I don't think, is what I'm saying. That I think the light is just, and then that's another thing too that's happening. Now, actually, this is something to think about. If you were at this point right here where this light is, I don't think anybody would argue that if you looked up, you'd be able to see a direct line with no clouds in the way between you and the sun for the time that the light is shining like that, right? I mean, it'd be a hole in the clouds or whatever, but your eye would be able to make a direct line of sight, or a straight line to the sun.
Mm-hmm.
And the same thing if you're standing over here where the rays seem to be going at a different angle. So what I'm saying is it could be that, I actually can't say I know or anything, but I just know that if the sun is so far away, and if the clouds are moving around, and because these lights, these lights that come down, these rays, they're ever changing as the clouds are moving. So it's an effect of seeing little holes through the clouds, basically, that the light can directly get through. And when I look at that, I don't see that being at all a straight line because of the clouds. I think the clouds would have to be basically covering the sky where these light rays aren't. You know what I'm saying? If they were straight, I don't know. Maybe I'm not making a point very well.
Yeah, I sent you actually another image.
Okay, I think is it? I don't want to display it unless. Okay, is it of a tree or is it of? I'm looking down at the bottom. Oh wait, let me. Okay, I can look at them. You can't see my screen.
It should be a cloud.
Oh yeah, with anti-crepuscular rays. Yeah.
Mm-hmm.
Yep, I got it, and I will put it up right now. And maybe I can zoom in on it. You think? Maybe not.
I didn't realize it was that small.
You know what? We can see it. We can see it. I think we know what it is. I can let me just do this. Anti-crepuscular rays. We'll just look at a Google image for fun. We might as well use Google while we can. Okay, so there's what it looks like from the ground, right?
Mhm.
There we go. And then when you look at them from above, the clouds, it gets very clear why they're like that. And that's the picture that Andrew sent us. And I'm going to actually go from above clouds, or just from above. That'll show it. There we go. There's a bunch of them. Let me find a good one. Let me do something. We'll go to tools and get a
That's the one
large.
that I had.
We'll get a large image. Oh yeah, it's right there. Okay. Yeah, we got a large image of it now. So
There you go.
I'll save it and then I'll put it in. I'll put it in the program so we can look at it a little bit closer. Because yeah, it is. It's clear that the sun is obviously on the left, right? Image, device. Where are we? Effects, image. It would be nice to have like software that you just said, do this, put that picture on my screen, on my YouTube.
Yeah. If you had Neuralink, you could just think it, right?
Yeah, I guess, right? Yeah, that's what they say. Did you hear what he was saying did you watch the latest Joe Rogan podcast with Elon Musk?
I have not, but I also have a pretty good understanding of what his plan is, and that technology is just not going to be available anytime soon for a very long time.
And then when it is available, it'll be like starting with one Lego, and they'll have to over time with people is the only way it can be truly developed, right? I'm saying once they have it and then they can safely put it into a person's brain. What are they going to do with it then? That's when they can start building it.
The technology has to be there first.
It would be like a phone app. That's what it'd be like. You had to have the phone before there was any reason to make an app, right?
Exactly.
Yeah. So I think it's going to be something similar like that. But again, I think that this is part of the end times mark of the beast or something like that. You know, I don't really know, but I think I think because of what Elon Musk is doing, you've heard me talk about fire coming down from heaven on the earth in the sight of man. You know that.
Yeah.
That's something that if you really start to think about that, it's for 2,000 years since John wrote that book, there's really not been a legitimate thing that was doing that. So this is kind of the first thing that's ever been doing that. It's very interesting. What are your thoughts on that? I'll get this image up. Sorry.
Well, I don't really know like what my thoughts on that are exact. Could you like explain that a little more, I guess?
Yeah, I will. Why don't we put that on the back burner since I got this image ready to go here.
Oh, okay.
And it should be okay. There we go. Uh-oh. It won't let me do it. Oh, there we go. But you guys are still seeing my desktop or not? Or no, you guys can see it now, right?
Yeah, well, I can see it through the thing. I don't know if...
Okay, I'm going to go and just double check once I fill up the screen. Okay, there we go. I'm going to make sure. Okay, yeah, we can see it now. So obviously the sun is low on the horizon. And I guess this doesn't really... I would expect to see that. I guess like if the sun was if it was 93 million miles away, I would expect to see that when it's low on the horizon. Or if it was 150 miles away, I would expect to see that on the horizon because the clouds are only so big. Now there would be a difference. If it was closer, you'd get more of a triangle than we see here. So, and this actually, to be honest, I got to be honest on Deborium's or for his side, or for like, I got to be honest. You know what I'm saying? This is not the best image, is it? Because in this image, they almost appear to do exactly what the image that we're trying to show that they don't do, right? They look like they kind of taper off. Let me
well, they kind of fade.
Yeah, but this almost makes them look like they're kind of like triangle or something, doesn't it? This is
Well, if
actually
you-
a cool image.
If you drew a parallel line, I'm pretty sure.
Yeah. Just I guess maybe I'm looking at the top one there, how it kind of fades off and gets smaller on the bottom. But I've
Mhm.
got another image that I'm gonna put up that's probably even better than this image for discussion sake. Let me remove that one and see the one on the right that I just clicked on there? That's the one I'm going to put in. All right, there we go. Open, create. There's so many buttons you gotta press just to get an image up. We got it though. Those are cool, huh? I love that. It's so cool looking.
That is a pretty cool image.
It's like it looks like the clouds are in the water, doesn't it?
Yeah.
That looks cool. So yeah, I mean, I do get that, but as far as okay, so we were talking about the distance of the sun, and the reason why I really doubt it is because not only because of what I was talking about, the shadows on that video I showed you, or whatever it, but there's another big huge thing that I think is important. And summertime, it's really hot out, and you know what I'm gonna say, don't you? The heat from the sun, how does that move through a vacuum or whatever, a near vacuum or whatever they call it? How does that move and manifest here? Simply because we're the first physical molecules that can heat up, or what?
Well, that's actually pretty neat. So it's basically light. Heat is the heat comes from the light from the sun. It's the light interacting with molecules that cause them to give energy, which then they move, which then makes heat. So light itself can travel through a vacuum, and we know that. And infrared, basically the light spectrum.
What's a thermos for? Do you know how they make a thermos?
Yeah, they put one bottle and then they insulate it with air around it.
Or with a vacuum around it?
Oh, vacuum
Yeah,
thermos.
they evacuate the air out of that intermediate part of the container. That's why it keeps the coffee cold, hot, and whatever drinks cold.
Because there's no particles
for it to
transfer heat.
Yeah, exactly. So that's what I'm kind of bringing up, is that it doesn't seem like to me that in a vacuum that you would be able to take a heat source and have it. If there's no molecules or atmosphere, I just don't see how a way for that heat to manifest on you know, a world that's 93 million miles away.
So if you put that vacuum thermos, in a microwave, you will heat it up.
Oh, for sure.
Now that's because of the light interacting with the metal. So the light has to heat it up directly. If that
I think what you're saying is, I think you're saying there's an energy coming from the sun or light that manifests as heat, right?
Yeah, the light interacts with the molecule, giving it some energy, and that basically causes it to move a little bit quicker. Okay. And that movement is what you feel as heat.
Okay.
If that makes sense.
Now, it brings up sort of another thing, is like throughout the day, you know, obviously it's like cooler at night or whatever, and then in the morning, the sun, it takes a little while until you really start feeling like the heat. But in the middle of the summer, like right away in the morning, right when the sun comes up, you can feel like tons of heat coming from it. And in the winter, the same thing happens, and you feel the heat from it, but it doesn't keep you warm or anything. It's like, why do we have these cold winters when the sun is lower in the sky up from our apparent position as we view it from the ground? During the winter, the sun appears to be much further south than it does in the summer. It's more above our head in the summer, which to me, again, go ahead.
So, basically, you're saying, why do we have seasons?
No, I know what you're kind of hearing about that or hearing from that, and I'm going kind of in a different direction, but we can talk about that too. The seasons, like how people say the sun's farther away in the summer than it is in the winter, or whatever. That's not the argument that I'm going for.
No,
I'm more.
no.
Go ahead.
The sun does change over like the I forgot the name for it. It's like aphelion and like something. The sun is at different distance, but that doesn't really impact the temperature of it depending on the distance. It's more of the
angle.
amount of light per area, if that makes sense. So basically the summer we're tilted towards the sun. Now that tilting doesn't mean that we're closer to the sun that causes it to heat up. It just means that the light is less spread out over an area. So if you have a flashlight,
well, it's literally the science would say it's literally the angle that the light is hitting the earth at. Yeah.
So you have a flashlight and you're pointing it at your hand, straight on your hand, right? It's really concentrated.
Yes.
So that means that energy from that light is in that specific area. So it'll heat it up a specific amount.
Yes.
But then you tilt your hand a little bit, and that light's going to cover a greater area of your hand now.
It'll start to stretch out.
Yeah, but that means the energy is not as concentrated. So therefore, it won't heat it up as much.
Yes, I agree with that.
Which would then result in seasons.
Okay, and that's where I'm going a little different direction, but I agree with you on the the basic action of the sunlight coming and the angle that it hits. I mean, we don't need to be even talking about the earth to understand that. We could be talking, like you were saying, a flashlight in your hand or just about any heat source that we use where it's coming from a light. Yeah. Like a light bulb,
It's basically the inverse square law.
Okay.
Well, not really.
But a little bit maybe, but I guess what I'm saying is, or what I'm trying to maybe question is, how do we in the winter? Now I'm not talking necessarily the distance of the sun. I'm talking about like literally from our bodies or from our position on the ground. Mm-hmm. A simple thing is that the angle in the sky that the sun is right now as it goes over, like let's say at zenith, right? It goes over, it's very high in the sky. I don't know the angle, but in 6 months from now or whatever, it's going to be at a much lower angle in the sky, and it's going to be much colder outside. And I'm not necessarily talking about the angle. I'm saying it appeared like a jet airplane that was above me would be closer to me than a jet airplane that was lower on the horizon that was flying at the same elevation or altitude. Just the apparent, and this isn't like something that we debate. It's just anything traveling away from you that's up above you is going to appear to go down. Yeah, perspective. So what I'm saying is, it appears to me that the sun is farther away during the winter than it is during the summer, from my senses. Like as I look at it, I feel the heat when it's right above me, and as it goes further south, we start to get snow. You know what I mean? Mm-hmm. That was basically the only point I was kind of trying to make there. But
well, let me throw a monkey wrench at you this time.
I'll take it. I'm ready. I got my monkey wrench glove ready to catch it.
As the plane example, the plane appears to get smaller the farther away it goes. But with the sun, it does not. It remains the same angular size.
Yes.
Throughout,
basically. It changes. It does change, but I think the change comes from the atmosphere.
Like the waviness and like the stretching.
Yeah. Yes. But I agree with you. The 15 degrees per hour, throughout the day, you don't see a smaller sun at sunrise than you do at noon. You see the same we could get meticulous and we could have a dumb debate on like very, very almost unmeasurable differences, because I know a guy, I don't know if you are friends with Dave Marsh or if you're the Amazing Moon
I've seen a little
Facebook
bit of
group?
his stuff.
Okay, so he takes pretty precise measurements of these things, and they do change angular size. But
Well,
a lot of that,
the moon is
the
a
moon,
lot closer,
yes,
and you
and
could measure that.
but he does it with the sun too. So
Well,
he does do the moon a lot. He takes a lot of stuff in the moon, but basically, I'm just saying that if we were going to be like reasonable, we would say that the sun doesn't change angular size pretty much ever. From the earth, from the ground. So to me, if we because you said airplane, its angular size gets smaller as it flies away and gets lower from our apparent position, which is true. But the sun, again, this brings up kind of that, I don't even know what the topic question that I would call it, like what the name of the question would be or the name of the topic, but it brings up that thing where I'm like, is this firmament world, where the sun, moon, and stars are, is there something about that world that we feel naturally that it's gonna be like our world, I guess, because we see it looks like a light, something burning or whatever, and it produces heat on our skin. So when we look at it, we're like, is that are we looking into a different type of realm that we don't that might seem to be one way as we look at it, but maybe, do you know what I'm trying to say? I'm terrible at explaining what the way I'm trying to explain it, I guess. It's another world like that our eyes would be able to see something from the ground here and everything, but it might not be physical or material, really, maybe even in any way. It might be purely celestial, and I think that maybe we don't understand that, or can't possibly understand that, maybe.
Well, I think I understand what you're saying, but with that type of thinking, I could just say that we're in a simulation right now, and we're all just thinking that the sun exists, and we're all just programmed to think the sun exists, but it doesn't actually exist, and it's going to behave the same as we observe it. You could have
it's a part of the simulation.
You could have a million explanations
for
the existence of the sun. It could be the unicorns farting, making it look like the sun's there, but we could never, or some wacky thing like that.
I get what you're saying. Saying. Go ahead.
But with that type of logic, that's not how really science is done. It's more of, you have an observation, you're like, oh neat, that's pretty cool. If this is true, then let's make a prediction. And then you use that prediction, you design an experiment to test that prediction. You make it an if-then. Like, if the sun's real and physical, we're going to see this type of radiation from it. And then you design an experiment, and then you test to see if you get that radiation. And that either confirms, it doesn't prove, it has evidence for. So you can never prove something in science, because there could always be that you're the only person that exists and everyone else is fake, and
no, I get what you're saying.
Yeah, so you go with that type of process and you provide ample evidence. Otherwise, it's just an ad hoc way of explaining it.
Yeah, no, I get you. Like, I can't disagree with that. Science there's a procedure or a process that I mean, it's only common sense, really, if you think about it. There's a leak in the roof. First I'm getting dripped on the head. Why is my head feeling drips of water hit it? Oh, yeah, because the roof above my head must have a leak. Well, there's pretty much only one way to figure out if the roof has a leak. If water's dripping on my head, we kind of know that there's some sort of leak. But if we want to really know, we'd have to go up on the roof, maybe pull a shingle, or what, we have to investigate and use our common sense. As human beings, we have this skill to do this. So that's basically what science is. It's a procedure to learn about something by gathering data from different perspectives and different outlooks and different beliefs even, and see what we come up with. And like you're saying, we can test and we can predict and we can do experiments and see these things. But like, I got to go back to the example of if the Earth is spinning, we would experience different weights at different latitudes. Well, that may be true. And actually, if you're saying you can predict with, like, if you go to the North Pole or whatever latitude you're at, you could predict generally what the weight change would be, which would be almost nothing, but it would be measurable or predictable, right? That's
Yeah.
kind of what you're saying. And what my problem with that is, it's not like I'm going to try to argue with that, because I've never done it, but like there, I saw Wolfie, whatever, that guy, he actually got a scale, and I saw his video and stuff. So I don't dispute it. I don't dispute that this is a thing that happens, but I don't relate it at all to any kind of Earth spinning, because I just don't think the Earth spins. Do you know what I'm saying? I don't have any reason to believe or to start out with, oh, the Earth is spinning. So we're like, if I had a scale and I weighed myself differently in different latitudes, I would say, hey, I weigh different over there than I do here. That doesn't really say anything about a motion or a rotation or a orbit. You know what I'm saying?
Yep. And that's what I'm talking about, the kind of like the prediction, because you could, that's just an observation at that point. It's like, oh, this is way different. But if you start out not knowing if that exists, you don't know if that's true or not, and you say, if the Earth is rotating, we would find this, and if it is not, we won't find it. So then you find the answer, and then you figure out if it like has evidence for or against. But with what you're doing, you're having the answer, and then you're deciding what's the cause, or like what best fits with it. And that's not really how that would I guess that's not like a logical way of thinking. You there, Joe?
I'm sorry, I had my mic muted. My bad. Let's talk about go a little deeper even than where we are right now, on the same topic with the weight and the rotation. This idea of predicting it. I just want to do kind of a mental exercise here. If I weigh different and it's predictable and it's on a scale that let's say you went up to the North Pole, you did the weight, and then you went 50 miles south and you did it again. You went 50 miles south and you did it again, all the way to the South Pole, right? So you had a very detailed scale of this weight change, right? Mm-hmm. And I believe that this is probably something that you could do. I don't know if anyone's ever done it, but we could do it. And you would say, okay, well, we're seeing that at this latitude, you're this weight, and at this latitude, you're this weight. I don't think that says anything about a globe. It could. I'm not saying it doesn't. It could, but I think that to jump to it being related to like the outward acceleration, or maybe that's not the right word. Basically the lack of, or the opposite that gravity is, or whatever. Like, it would pull you up or whatever if the Earth was spinning, right? I just think that that's such a small, weight change or difference or whatever. Even if it appears to be consistent with a globe, I still have to say, what is it? Not that, okay, we can predict the weight. I guess what I'm saying is, what is it that we can? How can we tie this to a rotation other than it being, what if it was coincidence is what I'm saying. What if you go here and it's this, whatever, you weigh this much? It does. To me, I start out saying, paying attention to maybe things that maybe weigh a little bit more on my, or for evidence, like the fact that the ground that I live on never moves beneath my feet. It never has. And the fact that the sun actually moves over my head every day, that's an observation that if I was up in the sky, it could be said that maybe the Earth appears to be spinning. But what I experience from the ground is that the sky is spinning and that the Earth is completely stationary. no motion. So that's what I'm saying. How do we jump from the actual, like the room you're in right now is not moving to you don't think it's moving, do you? I don't. and unless we're talking about relative to something in space, right?
Mm-hmm.
So it does
Well,
become somewhat intellectual of a decision over our observation.
well, I
A
don't.
little bit.
So basically, what you're saying is that's not enough evidence to convince you.
It's not evidence at all. And I'm not trying to shoot the conversation down, because I fully understand where you're going, but or your understanding of it, that it predicts and it does all these things, but it's still I still can balance you can balance a broomstick on the ground on a certain day. No, I'm just kidding. Remember that thing that people thought NASA was, it was just a big joke, but
Yeah.
with the broom, whatever. And I saw it on Facebook. I'm like, I don't think NASA said that. But
well, the thing about that is that's pretty good dang evidence. Like that's following the scientific method to gather evidence. I don't. You start with.
You're talking about weighing. You're talking about the weight of a person. It has really nothing to do with you. I can understand how you attribute it to being that out. Am I saying that right? The outward acceleration? Is that the right
centrifugal
term?
acceleration? It's more of
Okay,
just like
centrifugal.
angular momentum. It's like a fictitious force.
Okay. Would it be, I guess what I'm saying is how can we say, oh yeah, the Earth must be spinning because I can make a prediction about something like that, because that I guess to prove that the Earth would be spinning or rotating would be to prove that it's spinning or rotating, not like that you weigh different on standing on a scale. Do you know what I'm saying? It seems unrelated to me, even though I understand
it's a property. It's a property of a spinning body. That's what it would exhibit. So, okay, let's back up a little bit. So say I got a light bulb, right? Just in a room, and I want to know if the energy of that light bulb remains constant throughout. Like say it's gonna hit a piece of paper. I'm wondering if that same size piece of paper, being close to the light bulb, is going to absorb the same energy as a piece of paper far away. I don't know the answer, right? So I'm going to make a prediction.
Okay.
If the light gets less powerful as it spreads out, then the piece of paper will heat up less when it's farther away and heat up more when it's closer. Right? And this is without me knowing the answer to it.
Yeah. Yeah. You're
now,
just basically,
that's
a hypothesis, right? Is that what that's called? Yep. A hypothesis? Okay.
Yep. And it's like if-then statement. Yes. So then I do the experimentation, and I find out that the paper, when it's closer to it, gets hotter than the paper farther away from it.
Okay.
Now, that is direct evidence that my hypothesis was correct.
Yeah. Yes, I agree.
So I'm attributing that same process to the shape of the Earth. I'm saying if the Earth is the size it is and it rotates the speed it is, then at this specific latitude, I should notice a weight change of X. And then I'm going to go...
Specifically that much for that latitude.
Yes.
Right? Yeah.
And then I'm going to go to that latitude, and I'm going to...
And we find it's consistent. And
you find that it is exactly that it should be.
Consistent with your hypothesis.
Exactly. So therefore, that is evidence that the Earth is spinning. It's not proving the Earth is spinning. It is evidence for it.
How about this? I think we can actually come to an agreement if we say it different. Like we can agree on it if we say it slightly different. Because I totally understand what you're saying. But what if we said that that your evidence was, or how did I just lost the way I was going to say that? I had it on the tip of my tongue. Because I totally get what you're saying. But what if we were to say that that's evidence not of the Earth spinning, but it's evidence of you weighing less in that scale of all those different weights for different latitudes. I'm saying, how does that tie to the Earth spinning? Like, I know what you're saying. It's a location on the Earth. It's a real location, a real place, and a real scale and a real weight. But I still have a hard time understanding how that is really saying anything about the ground moving.
Oh, I see
It
what
says
you
that
mean.
you weigh different. Yeah, like, do you know what I'm saying? I'm not trying to.
Yeah,
like,
yeah. So, okay, so I'm gonna go back. So you take a ball, right, or like a tennis ball, and then you dip it in water, right? Then you got a wet tennis ball.
Yep.
And then you spin it.
Yep.
The water's gonna fly off of it.
As if the water weighed less as it spins. Yeah, I know.
That is
totally
caused
get you there.
by the centrifugal acceleration of
Yep.
the thing spinning, right?
And if the tennis ball had gravity in the center, you would just subtract then whatever free fall from that, right? Or
Yep.
you just subtract it from the free fall, I mean.
Yes.
Yeah.
And that will change how much it's supposed to weigh like on the thing. So if you expand that to the Earth, then if the Earth is rotating at that speed it says, and the same thing as the tennis ball, we're seeing if the tennis ball is going to be rotating. We find out that the acceleration at the equator is going to be 0.03 meters a second squared.
Yep. Okay.
So then we're going to be like, okay, so gravity's 9.8, and we're going to minus the 0.03, and we get 9.77 meters a second. So that basically means a kilogram is going to weigh 3 grams lighter. Now it would be 30 grams lighter on the equator.
Okay.
If the Earth was spinning.
Which is measurable, like you're saying, it's a measurable thing.
It's measurable, repeatable, and observable.
What if, now this is kind of like a silly thing that I'm going to say. I'm not trying to like actually make a argument or a point, but like, what if on all the different latitudes on the Earth, what if there was a different, basically what this is, we don't even have to really talk about weight at all, because we can talk about the rate that something will fall, and it's going to be different in the North Pole than it is on the equator, is what you're saying, right? Basically, yes. Because the weight of it is going to be subtracting less at the North Pole than it is at the equator from that 9.8 or whatever that.
Yeah, because there's no outward basically acceleration, so therefore it'd be just gravity. So then you wouldn't have any minus to it, so it'd be the most.
So maybe we can clarify our thinking a little bit, or at least get a different perspective by maybe we forget about the weight. We've established that if you take a scale, you're going to weigh different in the North Pole than at the equator. Okay, so let's say that's not a debate anymore. Let's just say that's just an observation that we've made. Okay, I've never made it, but I've seen videos, and I have no doubt that we can do that. Okay, so let's just say that it's more on the downward acceleration towards what you believe to be center of the Earth and what I believe to be just down. But let's just say it's a change in that. Okay, does that say it has to be something spinning, or does that say maybe it's in different latitudes on the Earth that it's a different that there's a different I guess gravity is what it's called popularly. I don't usually like calling it that because it seems like that would be only the center of the Earth. But what I'm saying is the downward force of something anywhere on the Earth that you are is going to fall straight down to the ground, which if you're on a globe would be the center. If you're not, it would just be down. Do you get what I'm saying? Can we clarify or get clarity by thinking of it that way? Or is that going to am I going the wrong way with that?
Well, so let's go back to the light in the room with the piece of paper.
Okay.
So I did the experiment, and now instead of coming to the conclusion that the light actually absorbs it, with the way you're going with it, you're just going to say, well, the paper just does that. And that doesn't show us anything about how the light behaves.
I get what you're saying. It would be ignoring the data that we gather, right? Is
Yeah.
basically what you're saying about the light. You know, if we measured it was hotter at when it was more at a different angle, and as you change the angle, it got less hot, or the two pieces of paper or whatever. I guess what I'm saying is, like what, you know, I'm trying to think of an example of something that could change that. Like even the atmosphere, like, what if the air what if there was like thicker air, like barometric pressure or something like that, and maybe that has an effect on, I'm not saying that like I think this, I'm just saying to me, it's a stretch to start tying that change in downward acceleration to a rotation. I see that more to be just simply a change in downward acceleration that possibly is consistent with a globe. But there's a lot of, like, if we're going to say that, you know, like I can't argue with that it would be consistent with the globe. So let's say it is. That doesn't mean that we're on something spinning or a globe spinning, because there's other things
it doesn't prove it. It doesn't prove it.
Is like there's several examples I can come up with that point out a serious problem in the idea that that the Earth is a planet in a orbit around the sun. Things like that. The lunar eclipse that was, like, I filmed it last night. I didn't see it, but it was a little bit hazy here, so I don't know. But I time lapsed the whole thing, and I was like, I didn't even upload the video because it was just lame. It's just the moon. But in a lunar eclipse, a penumbral lunar eclipse, the moon supposedly gets in the how am I trying to say this? The penumbra of the is it of the Earth, or is the sun hitting the Earth? Whatever it is, the penumbra in that shadow is like the bigger part of the shadow, and that's supposedly what the moon's moving through during the eclipse. And the problem is, a full lunar eclipse should have an umbra that's 280 miles in diameter. If during a solar eclipse umbra, it's 70 miles. Proportionally the same in the lunar to the solar. That's a big problem for me, like a huge problem for me. Where's that umbra during the when the lunar eclipse is centered on the ecliptic, like the Earth is in the center on the heliocentric? Why don't we see that distinct, very distinct shadow that we see during a solar eclipse? That's just one you know, I'm not necessarily asking you for an answer. I'm saying that points out a huge problem with the idea that the Earth is actually like in between the sun and the moon. There should be the same thing happening when the moon is between the Earth and the sun. It shouldn't be like a different law of physics for those two different events. Do you know what I'm saying?
Mm-hmm.
Is if we take a 2,100 mile in diameter moon, if we can create a 70 mile wide umbra with that, and we see it on the Earth, and it's very clear that it's a shadow, you know what I mean? Like, we can clearly see it going over us, and you can see it from above in an airplane filming it down. It's about 70, 80 miles or whatever. And that's for a 2,100 mile moon. So if we have a 2,100, or if we have a 8,000, 7,900 mile diameter Earth, I think the math works out to 260 or 280. I can't remember exactly, but it's right around 280 miles or something like that of an umbra that we should see going across the moon. We have never seen that. It's only ever like turns it red, turns it dark. And so to me, it just raises a huge, now, I'm not trying to necessarily change the subject. I'm just saying that goes kind of against the evidence of, because of the whole heliocentric model kind of has to be a whole package for all these things to work. Like, if the sun is 93 million miles away and we get one daytime, the Earth would have to be spinning one time per 24 hours. And you know what I'm saying? If something in that system is against that system, then that system isn't right. Or maybe I'm saying that model or that universe or whatever isn't understood right if we can come up with total big inconsistencies that we make with observations. What are your thoughts?
Well, the thing is with looking at for example, like the Himawari 8 satellite of an eclipse, you can see
Yep.
the very specific penumbra and umbra.
Let's do a little Google searching. How about that? And we'll look up some epic satellite images and the Himawari. Let's do that. You wanna?
Yeah, well, I can send you a link real quick.
Okay, otherwise I was going to do a screen share here and go to my desktop and see if we can't, here's my Facebook. Let's see if we can't, because there, I'm not actually familiar with the how do you spell that? Himi?
I sent you a link. It's like,
oh, okay. Okay, I will click it. Here we go. Because I want to show you the lunar eclipse from the epic too, because I believe that that's inconsistent with what I saw from the ground.
Mm-hmm.
And I know we've had this kind of a little bit of this discussion already. Okay, this will be a great image for us to look at. That is a great. Okay, replay that. I'm gonna pause.
Yeah, it's not the same eclipse from.
It's a different one or something, but
yeah, because it's a different side.
Solar eclipse, though, right? It's a solar eclipse.
Yep.
And so it's hard to tell, like a landmass. Can you see really? Let me go full screen here. Sorry.
China's on the top right.
Okay, or top left, maybe up here.
Oh yeah, top left. Sorry.
Okay, so so this would be like the penumbra, the whole thing, right? Out here.
Yeah.
And then we would have like right in here, we'd have a little 70 mile or 80 mile, whatever wide shadow, right?
Yeah, that's basically where like the total
solar eclipse. Yeah.
Yep.
The totality would be only in that path of totality is only about 70 miles wide. If you go north or south of it, you're not going to see the full totality, right?
Yep. Cause so if you're not standing in that like little 70 mile, all you would see from the sun is it being just like eclipsed a little bit. Partially
eclipsed.
Mm-hmm.
And the point, the thing that, this all makes sense, right? But what if our observations go against this? And I know which video I'm going to try to find up here of my footage, which I'm going to grab here in a second, of the shadow going over the one in 2017, totally inconsistent with like this Himawari image. And also, if we go to the epic satellite, it looks very similar to this size on a globe or whatever. It looks very similar to the Himawari one. I'm going to go find it. I think I know where it is. Flat Earth Proofs. I always say that because that's the folder that I have to go to for all of these monkey wrenches. No, I'm just kidding. Okay, Shadow Moon. So again, this is a time lapse that I took with a GoPro. And there's totality right there for 2.5 minutes and then done. So now it's the penumbra. Like when it's not that shadow, it's in the penumbra. And that shadow right there is not like the shadow on the Himawari, is it?
No.
Because of those sharp edges, right?
Mm-hmm.
I just have it looping. So what I'm saying there is, let me see if I can find an image. Sorry, again, I'm always going, let me see if I can find something. And then you guys all wait while I search for it. I feel bad. There is an image I want to share though, and now this isn't an actual image. This is a, if I can find it, this is like a Google Earth image or whatever. But the concept is there. Where is this? Uh-oh. I don't know where it is. Maybe.
Well,
I know. Oh, go ahead. Go ahead. I'm gonna try to find something while you're talking here.
Okay, so basically, from your observation, it is still not as bright as day. From your point, because the sun is still being covered, partially by the eclipse, by the moon itself. So therefore, there is less light reaching you. So there should still be a shadow, just not as noticeable as the penumbra.
And that's kind of what I was surprised by when I was there.
Mhm.
The guy I was with, I was like, is it darker out? It's darker out. And he's like, no, it's not. And I'm like, I thought it would get darker out. Like I kept saying that, like I thought it was get dark as it approached. And then it was that shadow that we seen on the GoPro footage. It was like that, and then it was dark. And then 2.5 minutes later, it was light again. Now I'm not saying that I measured the light with any kind of instrument, anything. So maybe my eyes need to adjust, and there is slightly a difference. What I'm saying is, if you look at the shadow on the Himawari or the Epic, it's gigantic shadow of shadow, and I didn't witness that when I watched it. What was I gonna? Oh, go.
Yeah. So basically, on that, the not as noticeable shadow, it's a more of a gradient that's gonna last a few hours. So if you have a few hours slightly notice, like a very, very dim shadow, it's going to be very hard to notice. If that makes sense.
Yeah, and that's kind of what because as we were going to, we had a kind of like a destination that we planned on going to so that we'd be in the totality, we were going to another state. I had no idea what's there. I don't know if if you go pull up to a park or, I don't know what, we didn't really know. And so he had looked and found some like camping grounds and some things that looked like they were open to the public. And we found one, but before we had found one, we were on our way there and we were like, dude, we're going to be late. We're going to be late. We're not going to get there on time. We might have to just stop on the side of the road and get what we can get, And I think we stopped in Lincoln, Nebraska, and it was maybe south of that. I can't remember exactly, but I took my camera out when we stopped at the gas station because we were like kind of in a hurry to get to that place where we planned on setting up. And I filmed, this was like minutes before the moon started to become visible in front of the sun or whatever, like before it started. And it was, it's a weird thing, but you'd think that you would see the moon coming up to it, and I didn't. So that was strange for me. Like because I had my P900, I zoomed in. I'm like, where is the moon? Like it should be there, because I knew that at what time the totality would, or I mean the eclipse was starting. And then you have, I don't know how long it was till totality. It was quite some time, maybe an hour or something till totality or whatever, however long. Maybe you said 2 hours. I don't remember, but I can't find this image that I was looking for. So I think, you guys are watching that shadow moon thing still, aren't you? I'm sorry. I thought we were back on the Himawari. I was going to point something out. Desktop. Okay, there we go. I was going to go to Epic. Whoops. Satellite. Satellite. I'll just do August 21st, 2017. Oh, look at that. This image, right? This image at the top here, that's actually the image I was looking for to show you how the shadow should look. Well, okay, now this is Google Earth, so it's not reality, but this is the umbra. This is detailing the umbra. This is not detailing the whole penumbra. It's just the totality that we're looking at here, right?
Yep.
And if you look at those towns, those blue lines are about 70 miles apart from each other. And what I'm looking at is when I watch that GoPro video, I see a shadow like this moving over the earth. I don't see one with a penumbra. Do you know what I'm saying? I don't see a shadow that has a penumbra. And I'm not saying on the screen right now, because this is obviously CGI or Google Earth or whatever, but I'm saying the shadow moon one, wherever that was right here. Sorry. This one. This appears to me to be consistent with that Google Earth video.
Mm-hmm.
It's a distinct like crisp edged shadow that was moving, however, pretty fast. I mean, it has to be moving pretty fast if it's 70 miles wide and it only lasts 2.5 minutes, whatever that works out to be. It's pretty fast. Was that 1,500 miles an hour or something? Probably pretty fast.
Yeah.
It is. I mean, I've never done the math, but basically, I guess this is actually a great observation. Now, I'm not saying I'm predicting anything. I'm not doing any math. I'm simply using just my common sense and some of the data that I've gathered, like the video footage here, and then looking at you saw the video where I took my drone and I had it on the road and I flew it up towards the sun so that the shadow stayed on the road. And there was never a shadow of a miniature drone on the road. Do you know what I'm saying?
Yeah.
If let's say my drone was okay, the moon's 2,100 miles wide. Let's say my drone is 2,100 millimeters wide. My drone never put a 70 millimeter wide shadow on the road. It only made the shadow less defined as I went up. It didn't change the size of the shadow. It got less defined, and there was never like a miniature shadow of a miniature drone on the road. So that, you know what I'm saying? That's consistent with it seems to be consistent with this video of the GoPro footage that we're watching on the screen here. So what do you think? What are your thoughts?
I'm trying to find, because I've done, like, I've used a golf ball, and then I use this really large light, and I've done the penumbra, and I've gotten a point.
Oh, okay. Now I can agree with that. I know you can do that. You can get an umbra, you can penumbra, you can see that, but not with the sun. Only with a light that's close to you, or a light, I should say. The sun is, I think, what we would have to use if we wanted to do like a demonstration or a experiment. Because I can take the light above my head in this room. I hold my hand up I'm doing it right now here. I'm holding my hand up in the air and I'm getting, I guess I can't really see the shadow very well. I'm getting two shadows because I actually have several lights in here, but so I'm seeing a shadow from all those lights. If we use just the sun as the source, it should be probably the best or the most accurate way to, to do science about it. You know what I mean? Like to observe it. What do you think?
Well, I'm just saying that if you try to, you'd basically have to make that observation when the sun is completely overhead. If that makes sense. So you get it. Otherwise, you get
I need to understand, what you mean. I'm not sure what you mean.
I don't know how to really,
like the angle of it, you mean, or
yeah.
Okay.
Because if it's not directly parallel onto it, you're gonna get it to not. You're not gonna be able to make
the shadow will become it'll become skewed in whatever it'll stretch. I know what you're saying. Yeah, if the sun's lower, if the sun is I get what you're saying now. Yeah, you're right. So let's say we did I don't know. It's something to think about though, because there's so many different factors. But like with the drone, I had to fly it slightly east as I flew it up in order to keep the shadow on the road. So the sun wasn't directly above me, but I guess what I'm saying is to do a proper demonstration or to experiment about it, I think we need to use the sun as the source of light. But that's neither here or there. I mean, I cut you off on what you were saying though about you doing with the light or whatever experiment kind of.
Yeah. Well,
go ahead.
Here, I found a really good let's see.
Here I'm gonna play in the background here the Discover Epic satellite. I don't know what channel this is or anything, but my computer's a little slow. It'll catch up. Don't worry.
Here
we go. So this is actually specifically the one that I watched. There's no way there's shadow like that on the Earth. I mean, that's why I don't understand, because if we look at this, I'll pause it here if I can. That is not I'm probably making a bold statement, but I'm just going to tell you that whatever we're looking at on this image, I don't even have, you guys aren't even seeing it. I'm so sorry. There, that might help. I'm sorry. This is the Discover Epic. I totally had the wrong screen up. Sorry, guys. Okay, this shadow. Let me play. I pause it. So let me. I'm not a very good host. Okay. This shadow here doesn't appear to be the same one as my GoPro shadow. It just doesn't. That's like a 500-mile wide shadow. It'll zoom in here and give us I'll pause it here and we can kind of analyze it a little bit. I'll let it get right to Lincoln, Nebraska. Okay, we're right over Lincoln, Nebraska. It's so small there. And Nebraska, I'm saying, Lincoln, Nebraska is just the closest town that we were to. But in Nebraska, that shadow didn't cover nearly the whole state of, you know what I'm saying? And then we're looking at it here and it's like monster. It's covering like 5-state area. You know what I'm getting at? And I'm not saying I'm not saying that Epic is like, this is some fake image, but what if, I really am starting to think that some of these images coming into us from these satellites in ones and zeros are not images. They're not, they are possibly coming from entities that can feed us whatever data we expect, right? That's maybe way out in left field, but I'm starting to believe that could be something that explains some of this. I mean, I just don't, I guess my main thing would be that observation. I'll play it again here. This one, this observation on the screen right now, to me, does not match in any way to this observation that Epic makes. What's your thoughts on that?
Well, all I'm saying is that you wouldn't noticed that larger shadow takes probably about 12 hours to cross. It's a good amount of time.
Yeah, I think it's more like maybe 3 or 4 hours, maybe 5 hours.
Well,
I think maybe 5 hours, but I know what you're saying.
That's a very long time to have a slow shadow gradient.
Okay, but let's take, I understand what you're saying. Like our eyes probably certainly wouldn't notice the first hour and the last hour. There would be no difference that our eyes would pick up, right? Something like that is what you're saying, because it's such a small difference. But as it gets deeper and thicker towards the center of the shadow, and then it goes further out to the penumbra or whatever, then what I'm saying is, where is this? Where is this in that? This distinct line that's only 70, because it goes from light to dark. And so I'm like trying to tie these two together, and my mind is like, no, that's not what we're seeing on the Epic satellite. It looks nothing like that. But then the Epic satellite, it's obviously a very large shadow, but where's that distinct umbra at? Is it just kind of in the middle there? You know what I'm getting at?
Yeah.
I'll go back to this. I'll just play this video for a little while. Yeah, I don't know, man. It's hard for my mind to, because I'm like, any flat earther will be like, well, it's just a fake CGI image that NASA made like in their back room to fool you. And I'm like, no, I don't believe that. I think that they put a satellite at Lagrange 1 and that's where they believe it is. That's what it is. And this image they're getting is coming to them from whatever transmitter they put on that satellite. Okay. But it's scary to me to see these totally two kind of contradicting each other images and know that I guess I don't doubt my own, veracity. I know that I put the GoPro on my truck, and I know that I just time lapsed it and I didn't edit it or anything. So what I'm saying is, like, what is this that we're looking at? I really don't understand. To me, it's entirely different, but that, maybe that's just me. I don't know, but so that's one. We got kind of like way further into that than I expected. That's okay though.
Yeah.
Yeah. So what are you thinking there? Or I guess just the we were talking about if there's an inconsistency at all, then it kind of seems like, or I was saying this, I guess, that it kind of seems like to me that there's more than just an inconsistency going on. There's something I can't explain it. That's what I mean. I cannot explain it. Oh yeah, this was oh, go ahead.
All I'm saying is that people have the Umbra and Penumbra. It should be like that, because the sharpest shadow is going to be at that 70-mile range. That's going to be where the biggest difference in light's going to hit.
Yeah, and I'm observing that was the only shadow.
Yeah, and
there is no part of the other. There is no, like, I understand the concept of a penumbra, and we can demonstrate it with a light of our own, but we can't demonstrate it with the sun. That's the tricky part.
Well,
they say that we can, but I've never seen it done. I tried it myself with my drone. I flew it 300-400 feet in the air, and there was no. What I'm saying is, I should have seen a miniature drone on the ground. That's literally 1/30th of the size of the drone. That's what the heliocentric model claims happens during a solar eclipse. That this, well, it does. I mean, it says that there's this 2,100-mile object, and it somehow casts a distinct 70-mile wide shadow.
Yeah,
so
I
it's
just
something to think about.
I just sent you a link of someone doing what you said they couldn't. So.
Oh, okay. I'll check it out. Oh no, that's good. That's good. That's called a monkey wrench in my business.
Yeah.
No, that's why we have these conversations. I want to learn something new if I don't know it, or if I already know something and I think that you're misled about it or believe in something that I don't believe. I'm going to tell you, you know that, and I know you're going to just tell me too.
Yeah.
That's great. I think that's the whole point. That's the whole point. Let me just search this for a minute. We'll just watch a little scenery in the background for a while. Now I'm going to go grab your link. I just didn't want to show everybody all of my Facebook messages and everything.
Yeah.
And then I'm also going to add this, just because if you're not subscribed to my channel, please do hit that red subscribe button. And if you go to the description of this video, there should be a link to Deborium's channel. He does some science there, some experiments, some demonstrations, some chemistry, and some debunks, flat earth debunks. Go check his channel out. He's definitely a smart guy that is interested in, I think, important topics. I think they're important, but that's just me.
Yeah.
So yeah, definitely go there and then subscribe to his channel if you guys haven't. Maybe, you know what, maybe if you want, or it would be easier for me to do that, I think. How do I do it? Oh, I can go to I was just going to put the link in the description or in the chat room, just so it's convenient for people. Look at that. We got 3 thumbs down going. Woohoo.
Oh,
3 thumbs down. Yep. They don't like us.
Doing that? Who be doing that?
Yeah. Who'd be doing it, and who'd they be doing it to? Is that towards the globe or is that towards the flat? I'd like to know.
I don't know, man. I don't know.
Could be either. That's the beauty about thumbs up and thumbs down. It's totally what's the word I'm looking for? nobody knows who did it.
Yeah.
So, okay, we're at the whoops. I gotta do a desktop share. I always forget that. I always start talking. And you guys are probably all like, "What are you talking about, man?" Let's see, desktop. There we go. Deborium's channel, and I'm just showing you so you know what it looks like, and then I'm going to go to. Whoops! I have to hit the back button, and we're going to put it in the chat. You know what the music we're listening to? If you can hear it, it's really quiet, but it's called. It was something I downloaded from YouTube, and it was called "The Best Hacking Music," like for computer hacking. So I was like, "Yeah, I'll use that. We're gonna computer hack today." Okay, yeah. Click the link and subscribe to Deborium's channel. I think we're probably gonna wrap it up here pretty soon.
Yeah, it's
and
too bad Thomas couldn't come out.
Yeah. I think he's probably. I'll bet you anything because he told me that typically, and I don't know if it's different on his holiday, the weekend or whatever, but typically, I think he said he goes to bed around 6 p.m. Unless, like, because I think he works. I don't know what that would be, second shift or third shift, whatever. He's usually driving at night, pretty much, and in the early morning, I think. So he drives truck. I don't know how to do that. So
I have to get up pretty early for my job too. I have to get up at 5, but I don't know. He might be getting up at like 1.
Yeah, who knows? Yeah, or even it, like, depending on how much sleep a guy usually gets, he maybe even starts at like 11, get like 4 hours or 5 hours of sleep. But for a trucker, I think you need to get more than that. You gotta, because you're trying to drive a truck with your eyes open all day. Sometimes that's got to be hard. Like when you're tired.
That'd be tough. That'd be tough.
All right. I wanted to first of all say thanks for everyone that showed up and hung out. And then the other thing I wanted to say is that me and Deborium aren't done here.
No.
This could be a long conversation. Like, could go on for years. This debate. I'm just kidding. But yeah, definitely we'll be on again with Deborium, and we'll be discussing these things. I enjoy it. I think it's fun. And I think actually people in the chat enjoy it, even though there's some thumbs down. I think the thumbs down are just because there's a globe guy here, myself. But hey, whatever it is.
Haters gonna hate.
Andrew, haters gonna hate. If you knew Andrew, you'd probably not do the thumbs down. You'd be like, oh man, this guy's cool. Even though he lives on a spinning ball, it's still fun to talk.
No, we all do. We all live on a spinning ball. What are you talking about?
That's what they say. Maybe I'm the weirdo, but I'll tell you what, I don't think it's spinning. We kind of talked about that in detail a little bit. But yeah, you guys, thanks for showing up. Cindy Lou, Kelly, Flatjacks, all you guys, for hanging out because, yeah, it's fun. But we've been going, how long have we been going? We've been going 2 hours and 18 minutes. Wow.
Yeah.
Actually, about 2.5 hours. We were on a little bit before we went live. So we talked about all the good stuff before we went live. And then, so maybe we'll share that with you next time.
Yeah.
I'm just teasing, of course. So you got anything you want to share? Any information about what you've been doing on your channel or anything like that? Feel free, say anything you want. And we'll probably wrap it up.
Okay, I guess if anyone ever wants to talk to me or debate me, I'm always willing to. I think that'd be a lot of fun. And yeah, I'm not really too active on my channel right now because I'm working kind of a lot, but maybe later in the year. But yeah, thanks for having me on.
Yeah, no problem. Thank you for joining me. We've done this a lot of times now. Like every time we do it, I feel like we kind of even like, it doesn't mean we're going to see eye to eye on these things, but it's important that we search these things out, right?
Yeah.
I mean, I think everybody wants the truth. Nobody wants to believe a lie. And I'm the guy that's in the middle of the room, like holding the weird sign that says it's the end is coming. You know, I'm that guy. And I'm like, we're believing a lie. So that's just who I am. And that's where I'm at. So when I can talk to someone like Deborium Channel, who I got a lot of respect for, and and actually his dad and uncle that I knew, uncles. I forgot about BJ. Is that three? Was it just the three brothers? BJ, Mark, and Matt, or was there more?
There's more, but those were probably the ones you went to school with, because we got.
Yeah. I wrestled on the team with all three of those guys. So those are the ones I know. But those guys, they were always very cool, and I actually I looked up to Mark and Matt quite a bit, because they were the older kids, a couple years older than me, and on the wrestling team they were the captains, and so they were the guys that were when we were running in practice, and they'd be like, "Get your butt running faster," like that. They're good guys.
Yeah.
Worked us hard, and I always had yeah. Isn't that weird how you never forget that kind of stuff? Someone sets a good example for you, you never forget it. So set a good example anytime you can.
Yeah.
And so thank you, Andrew, and thank you guys for showing up. And we will probably sometime midweek I'll be coming on again. Maybe Andrew will be back, maybe not. Maybe Thomas, maybe. Oh, and then one more thing, Deborium. I opened my messenger and I went to Nathan Thompson. I'm going to drop him a message and see if we can't get together. That would be fun, wouldn't it?
Yeah, that'd be.
He's a great guy. I think he gets he's really sick of the, how the Natalie and there's a lot of insults that are kind of all right. It gets old. And for Nathan, he gets his little Kent Hovind SpongeBob out and stuff like that. It's funny, but
yeah,
if you actually have a genuine conversation with Nathan or a debate or something, he's really full of information, and I disagree with a lot of it, but that's where I can, I don't know. A lot of people really avoid me just because of what I believe or what I say. And I'm learning that the people that don't avoid me for what I say, but they'll have a conversation with me, I like those people.
Yeah,
I don't like the people that
gotta have a conversation.
Just block me off. A lot of people just block me off because I say some things that maybe they're not ready to hear, or they don't want to hear, or whatever. So Kelly Lowry says, yeah, I agree. Joe keeps his cool so well. I'll tell you what, I got a kind of a interesting story about that. I think I've told it on my channel before, but it's actually a joke. But I was invited to be an astronaut, which everyone that is familiar with my channel has seen that, yes, I am an astronaut on the ISS. I'm not in real life. Not in real life, but on Facebook and YouTube, I play an astronaut, and the captain much of the time, the commander of the ISS, Joe Hill. So they invited me up there, and I was like, why? And they said, well, they're having a hard time keeping it cool. So I went up there, right? And then, so then I went up there, and it gets boring up there. You look down the earth, you're like, yeah, I've seen it. And all of a sudden, I'm like, I'm going to bring some books up, read a book or two. So I've got a good book up there, and I was reading it, and I could not put it down.
I see what you're doing.
All right, guys. Had to have some dry humor there. I just was reminded of those jokes yesterday, so I'm like, might have to tell them again. So, all righty, everyone have a good night, and thank you again, Andrew, and God bless everyone, and thank you for hanging out.
Yeah, thanks for having me.